So I've got this Rangehood here in my kitchen here, and it's playing up. I'm going to show you what it's doing in a second, but I just want to give like an overview first. Basically, pushing buttons and it'll shut off. It's like a power supply problem, I believe. After it's had a chance to warm up a bit and it's been on for a while, then you can actually turn on the light and the fan at the same time. It used to be able to do both, but now you can only do lights or fan initially, then after a while you can turn the other one on and it will work. So I think it's a power supply problem, probably bad capacitors, but we'll get into that. So I'm going to show you what it does. So let's turn it on. Sometimes it'll do that as well, it'll cut out when you first start it. That's running one fan. Well, speed 1, 2, 3. Right. Same thing about pushing this button here. I don't know if maybe there's an issue with the control. I don't know. But if I turn the light on, it's cut out. And sometimes when you turn the light on, it doesn't go. It'll cut off. So I'm going to do it now because I've been playing with it. But turn the fan on. No. No. So it's won't let you do it. See? Can't do it. So yeah. Don't know what to do. So I think it's got a power supply problem. Now the power supply is like a big brick, which is up in the top there. It's about halfway up above the fan assembly. This is just like a shroud on here. I've got to pull this housing off here and have a look at that brick. Notice its mains powered. I'm a bit careful about what I'm doing. Put it, unplug it, and maybe if I can disconnect it and bring it down, I'll do that, and then we'll look at it. But I'm expecting it's probably bad capacitor or something like that. We'll give it a go, see if we can fix it. So I've already pulled off the first shroud, which just sort of sits around it in this case. I think it's supposed to actually go behind it, but it's not. It's around the outside. So I've lifted it off. The top one's got 2 screws, I'm going to take those out. I'll take the top shroud off. And just in between that gap there, you can see the power brick. But I just want to get the top shroud off, so it's all out the way, so I can see what I'm doing easily. And we'll go from there. Hopefully I don't fall off and hurt myself. Have to wear the correct shirt. Right. So this power, turn it off. Give it that. Brick. There's also a device here which I think is just for the lighting. Yes, that's right, it goes through, goes to the lights at the back. So this is a 11.5 volt output. Must be mains coming in from this block here. So it's got some screws on top of here, so I'm going to have to take the top off. I want to take the whole thing off the unit, obviously, so I can work on it. Okay, here's the cover. And what's inside here? Well, some control circuitry, some relays, big cap here. It's probably got a charge left in it, so be careful what I'm touching. And a little bit of electronics, a couple of capacitors in there, which look fine, so that's a bit concerning. I'll see if I can lift this thing off the unit. But from what I can see in here, there's not really much to go wrong with it. It could be this big cap here. That connection's not looking very good right there. That's half off. Maybe that's what's wrong. You never know. Yeah, there's really not much to go wrong there. I might bring the camera up here so you can have a look rather than unscrewing it. It might be bolted through into the inside, so I don't want to risk loosening bolts off. if it's a self-tapping screw, it's alright. I'll bring the camera up here now. Okay, so I apologise for the shaky camera work because I'm hand holding it. But there's the control box there. So you've got this big capacitor just here, obviously for the motor. And this connection here is a bit loose. It's only half on there. I don't know if you can see it. I don't know, it's not looking good. Maybe that's what's wrong. And there's not much else in there. So sorry about the lighting, it's not great. I mean, there's a couple of capacitors in there, so maybe it is worth pulling it down, having a look. But I'll see how hard it is to get it out. If it's not too hard to get the whole unit down, then I'll do that. Look at it on the bench. Okay, here's the control board. I've got it out quite easily. It looks like it's actually designed to be fit and removed quite easily to change it. So it's got 4 screws and it's got some connectors. So you've got a mains line in here, which is marked as red, you can see. It's a red connector. So that's the mains coming in. This, that says ionizer. It's actually going to lamp, interestingly. That was supposed to be lamp. I'm not quite sure why they're back to front. That's interesting. They're in parallel, it doesn't matter. But they had it plugged into the wrong place. Go figure. That's the motor output, so it goes to motor control. This is the control input here, which is obviously goes to the front panel buttons. And as you can see, there's not a lot on it. It's got a transformer and a little power supply. Got some diode bridge down here, rectifier, and some control transistors. So these transistors will be running these relays here to switch each output. One is obviously for the ionizer and lamp. And the other 3 will be for the motor stages. Let's have a look. And sure enough, there's a relay controls there, lamp, and each motor for speed. So yes, it's basically this little power supply down here. There you go, 78L05 right there. So yeah, 5-volt voltage regulator, and it's some kind of chip. I'm not going to take that label off. It's probably some little microcontroller. It may not even be a microcontroller, it might be something else. Actually, maybe I will just peel that label back and just have a little look. But I don't know if you can see it yet. This capacitor here, it is very slightly domed. Can you see it's bulged through slightly at the top? If you get the light on it right, maybe you can see it bulging. So it's curved. So that capacitor's had it. So I'll change that. I'll just change all the caps on this board. But the bottom of the unit looks fine. I mean, it looks like it's actually conformally coated as well. Yeah, it is conformally coated, so that's quite nice. You know, isolation when you've got the main side coming in. So this is all mains on this side, and that's all low voltage. So there's a nice isolation gap there. No slot, but that's a pretty decent gap anyway. You know, it's probably not really an issue. Yes, the neutral just goes straight through. Neutral straight to that terminal, this terminal. Just passes straight through, no interconnection. And obviously just a transformer here. 130 degrees, so it must have a thermal fuse inside there as well. Somewhere. Probably inside one of the windings. And these are relays using 10 amp, 125 volt or 5 amp at 250 volts. So these are rated at 5 amp for my situation because I'm 240 volt. So yes, that's a close look at that side of the board. And I'll flip it over. And it's a close look at that side of the board in case you want to reverse engineer it or something like that. You know, try and get different views so you can see better. Yeah, that's the one. I'll do it. There you go. So yeah, but that cap there is definitely bulging. So let's have a look at this and see if I can peel this without destroying the label. It's practically falling off anyway. This makes it a bit easier. Get some tweezers. Just falling off anyway. So what is it? Oh, it's this pin one there, so that's an M logo, Motorola part. As with these things, it's always a bit of a challenge trying to get the light on it right so you can see it. CF745. No idea, so I'll put it some custom part. Is that Motorola? I think it is, isn't it? So 07011V0. So it's probably some custom part they make just for this. Let's fix this thing. I don't really care about that. I mean, it's just a little controller. You just push a button, it'll bloody do stuff. It's not really that complicated, is it? Let's look at the control side of it actually. What can we see from this? So you've got some resistors there, 10k. Actually, the values are marked on the board. That's quite nice. 10k going to that pin there, which is probably a common rail. Yeah, it's regular common. Yep. Let's pull down. So it could be the centre pin of that regulator. So that's the negative, isn't it, on those regulators. The positive would be this rail here. Across the buzzer, so switching negative on the buzzer. I think I'm reading that right. Yeah. So it's pretty simple. There's a little controller there with inputs which will be switching the outputs through those transistors. So obviously you've got some smoothing with these caps here and the resistors just to create, you know, reduce spikes, but also the main power supply's failed because that's across the main rail, and that is on the input to the regulator. Yep, into the input of the regulator. So there's obviously just AC coming through there which is causing things to switch off. So we'll replace that cap and then do these other ones. Now being conformally coated, this could be a bit fun. So 25 volt 1000 microfarad. I might be able to put a better one in there actually, might be able to put a bigger size in. So here we go. Let's try and push this out. I could get my desoldering gun going, but I really can't bother. Alright, so let's replace this one. It's definitely bulged. Let's just get my meter out and just test it. Trying to touch the terminals at the same time. Yeah, that's not right. Dissipation 1.7 ESR is going to be 0.7 kilo ohms, so yeah, definitely fried. Definitely gone. Anyway, that's at that frequency obviously, but different frequencies give different results, but that's, I can bother changing frequencies. So what does it say it was? That's 1000 microfarad, wasn't it? 25 volt. Right. Next size up is 2200, but anyway. So there's another cap here, basically the same. Right, this is a Zhao brand. There you go. Zihui? I don't know, some Chinese rubbish, obviously, never heard of them. I'm going to put in an Inchicon, because, you know, that's what I have. Good ones. Maybe I'll do the right thing here, make sure I put it right around. Okay, here we go, straight in, and those leads out. I'm not going to solder that just yet. Now, I've got these other caps in here too, which I should probably look at changing. Get slightly closer. They're actually mounted on the board, which is quite nice. I mean, I'm actually surprised, actually, to be honest. Maybe it's just... I'm surprised. That's actually really nice. I should look at the PCB number as well. SH67B-7.PCB Ver2.0. 6520. So does that mean 20th of the 5th, 2006? So that's 13 years old. Yeah, that's alright, I suppose. And just things have been playing off about a year, so I've kind of been putting it off. Anyway, it's pretty easy, so I don't know why I put it off so much. Right, so let's get this one out, which is supposed to be 100 microfarad. Might have to put some fresh solder on this. This conformal coating. It's affecting the conductivity of the heat. Right. So I think, well, I might as well just place them all while I'm in here. Right, so 100 microfarad, 16 volt. It's pretty small. Physically small. What brand is this one? This is a Sencon. Never heard of them. Let's see. 16 volt. 25 volt, we'll upgrade it. And then the last one, say 47 microfarad, 10 volt apparently, which is it's another Zihui brand. Anyway, we'll get it out. Put these caps in, I've done with it. I'm going to mess around with it again. This will be it for the lifetime of the unit, hopefully. 47. $47.35 volt. What brand's this one? This is a Machita brand. Have we got any other ones? I've got some lower quality ones in here I can get rid of. No. Sometimes I do. I've got Rubicon there. Though that's not exactly real low quality. That's 25 volt. Right, let's drop this in. This is why it would be easier to use the soldering gun, because it will actually leave the holes empty. But it's not really that much of a hassle on these things. 2 dead components, not really a big deal. Right. I don't know why I had that one lying down. It doesn't need to lay down. I lie down anyway, even though it doesn't seem to actually need it. I push it away from the legs of that IC a little bit too, because it's basically touching it. There we go. Alright, solder these in. What I'm just going to do is push that part on, make sure it's seated properly. Okay, that's it. It's flat on the board. Now wake up, don't go to sleep. This tip I'm using is a bit small for this really, but it'll do the job. The conformal coating's getting in the way a little bit. It's a very thin conformal coating, there's not much of it there. Same thing on that one, make sure it's seated down on the board. So it's out of focus, but I can't adjust the camera right now. Problem being zoomed in like this is that it goes out of focus very easily. Come on. Out of focus again, aren't I? Of course I am. Alright. Solder now, let's get that off. So this tip's a bit small for this, so I struggled a little bit to do this, but anyway, bring these up. And it should now work, I reckon. That should solve the problem. I highly think it will. I really do think it will fix the problem. Let's just look at these other capacitors which I pulled out. That just gives us a clean, does it? The longer you leave it on there, the harder it is to clean. I'm liking that solder joint very much. Log in there. Doesn't really matter too much. I mean, it's not like it's sort of going to be affected by a little bit of flux on the board, but I just like to do it, even if it's roughly done. Alright, let's check these caps out. These other ones which are pulled out and see what they look like. I'll even put it on the right frequency scale this time. So, series capacitance, frequency, I'm going to, I suppose 1 kHz would be right for small caps anyway. We'll do 100 Hz anyway. Right, let's see what we get. Oops, bend the legs in, a bit flimsy. So dissipation of 0.1, 40 microfarad, 47, so it's reading a bit low. Just change, oh, Not what I want to change. I want to change frequency. I want to change the ESR. 5.6 ohms. Yeah, I think that's getting a bit up there. Okay, let's check this one. Yeah, this one's had it as well, like 18 microfarad, 90 ohms. Yeah, that one's also bad. It's that Sancon one. Let's look at dissipation, see if that makes any sense. Dissipation of 1. Yeah, that's definitely bad. And we'll try this one again, this for different frequency. So 1.5 dissipation. Here, less than 1 microfarad. Okay, I reckon that'll fix it. That'll stop the AC coming through the electronic circuitry. Let's go and put it back together. I bet you it works now. Alright, so I thought I'd give you a different view. This is the top here. You can see how dirty it is up here. Years of grime, as you get. So, obviously here's the mount. Here's the board. Sorry about the lighting again, because there's only one light and it's right over there. It's not really designed for lighting up here. So this board sits in there just like so. Okay. So I've got to put those screws back in and secure it, then I'll put all the connections back on. And then we'll give it a try out. So I'll put the tricky screw in first. This one's just a bit hard to get to. I'll try and start the light if I can. Try and start the light, there we go. Let's lean right over. Time those up. One. Okay, I'll plug these in. So we've got the AC first. Well, we should do that last really, but anyway, I'm not. There's the motor control. I'll get it down. Then we have this one, which is the light, which is supposed to go to there. So I'm going to put it back in the correct place this time. I should run it around the back of this one, actually, so it's tucked inside. This one's actually easier to get off than the other one. Let's move it like that. Just tuck that away again. This thing's sort of tucked around like this. Now we've got the control circuitry here, which runs down, plugs in there, like that. Okay, and I've got that back twisted over as well, haven't I? Put this back out. I could run it around that way. It's got to come from the centre though, so I think I'll uncross them. That might be wrong from the beginning, because I'm pretty sure it's supposed to come to the middle like that. I think it was already wrong. Yeah, okay. So unplug that. Let's tuck this under here. Then run to there. Like that. There we go, that's much better. Okay, we'll run that through there. It's still multiple insulation as well, it's like double insulated and stuff, so it should be fine like that. It's all got to run through the same connection anyway. Tuck down inside here. I'm going to push that down through the housing actually. Get the slack out of the way. So there's the capacitor which is supposed to be in here as well. I'll push that through the housing a little bit too. I just want the slack to be inside the housing rather than inside this box. So that's got this. So I'll push these connectors all the way now. They weren't fully on. So let's just get the screw in there. And here you can see that ballast, well, the transformer for the lights there. Screw this in. And we can try it out. But I'm pretty sure this will fix it. I'm sort of 90% sure that'll be the end of it. Sorry, the light's in the way again, aren't I? Right, that's it, that's screwed down. Slightly tighter. Okay, everything should be tucked out of the way. I think we're good there. So I should be able to put this housing on. Now it's got to rearrange these wires to get them in the right places. Is that why they had it on that other one? It doesn't quite reach. Ah, okay. Right, that's why. The wire's a bit short when it's over here. It's supposed to go to the centre hole on the housing, not there, so okay, we'll put it back in the other one. That's why I did that. Because then you can reach the centre. Just. It's not the best bloody setup, I have to say. Anyway, it's on there. Those are through there, great, and put our screws back in. And then we're done. I'll put the housings back together. There's crap up there. It's dust. I have to get the vacuum up here afterwards. Okay. Let's try it out. Right, moment of truth. It's plugged in, it made a reassuring beep when I plugged the power on. Right, let's go with my fan. Light. Yay. Okay, off. Full fan. Light. Yes. It's fixed. There you go, it's fixed. Yeah, that's how you do it. No, yeah, easily fixed. It's better than replacing the whole bloody unit. 3 capacitors, 3 caps. So there you go, that's that fixed. I hope you liked it. Make sure you subscribe if you want to see other stuff we try to fix. Not necessarily household things, it's usually electronics, as you saw from the power supply repair on this. So if you're interested, make sure you subscribe, click the bell icon, that's extremely important. If you don't click the bell icon, you won't receive notifications about me publishing new videos. Very important. If you're already subscribed, make sure it is already clicked to say you're going to get notifications. It's very important. Otherwise you won't hear from me, and you don't want that. You know, I'm sure if you subscribe you actually do want to see the subscriptions. I also highly recommend that on your homepage you've got the subscriptions page. Bookmark that page and make that the page you go to when you come to YouTube. That way you go straight to that page and get to see all your current subscriptions, what they've posted that day or the past couple of days. And that way you're less likely to miss things as well. Because YouTube doesn't always tell you what's been around. You'll miss a lot of stuff because there's just so much out there. So anyway, catch you later. See you next time. Bye. So I've got hundreds and hundreds of videos, so if you haven't seen my previous stuff, then make sure you go and look. I've got hundreds of them, like 644 videos I've done so far. Go back and look at the back catalogue. Pages and pages of them. Go and check them out. Make sure you go and watch more stuff. Watch more. Watch more. Watch more. Yep, that's it. So there we go. Watch more.